Hi, I'm Brian Sam-Bodden, developer advocate for Redis, and today I want to walk you through the steps of creating a Spring Boot application powered by Redis Stack using the Redis OM Spring Java library. Redis Stack provides a simple and seamless way to use different data models and functionality from Redis, such as our document store, the graph database, a time series data structure, probabilistic data structures, and a full text search engine. So now you have your pick of data structures and features to build streamlined and efficient applications using the right data model for the job. Redis Stack is supported by several client libraries, including Node.js, Java, and Python, so developers can use their preferred language. Today, I'm going to be using one of Redis Stack's supporting libraries, Redis OM Spring. Redis OM Spring provides powerful repository and custom object mapping abstractions built on top of the powerful Spring Data Redis framework. And now I'm going to switch to star.spring.io, the Spring Boot starter, so we can start building our application. So now I'm going to switch to the Spring Initializer. In the Spring Initializer, it's this nifty website that allows you to create a skeleton for your Spring Boot application. If you're a Spring developer, you probably use this every other day. So we're going to build a Maven project using the Java language. We're going to stick with the Spring Boot release, which is 2.6.4, and we'll make a few changes here to our project metadata. So I'm going to start by moving everything under the redis.com package. Our artifact is going to be called skeleton, since we're building a skeleton application for Redis Stack. And let's switch the description to skeleton app for Redis OM Spring. Everything else looks good. Packaging is going to be a jar, and we're going to stick with Java 11. Now, on our dependencies, we want to add a few things in here. Since we're going to be adding a web services interface, we're going to add the Spring Web dependency. And I typically use Lombok, so I don't have to create getters and setters and all that crud. Also, let's add the dev tools. We'll add the dev tools so we don't have to do restarts on our application. Okay, that's sounds like a good start. All right, then I can click generate, and that's going to create a zip file that I will unzip and import into my IDE. So now that I have generated the application using the Spring Initializer, I'm going to unzip it and import it into my IDE. And today I am using SDS, which is the Spring Tool Suite 4. It's an Eclipse-based IDE. And yes, I'm using Eclipse, and I kind of like it. All right, so let me switch to SDS. And here we have our project. And as you can see, it's a traditional Maven Spring Boot project. We have a main application, which has the Spring Boot application annotation, and a main method with a runner for the Spring Boot application. And then we have under our POM, we should have the generated POM with the dependencies that we set out. The web, DevTools, and Lombok. All right, so now what I'm going to do is I have everything prepared as commits in here, and I'm going to add the Redis OM Spring dependency to our POM. So now, noticing here under dependencies, we have our Redis OM Spring library. It's version 0.3 snapshot. Since this is a snapshot version, I need to add also the snapshot repositories from Sonatype. So that is in this repositories block. And we also want to use Swagger for our endpoints. And Swagger basically gives us a web UI to test RESTful endpoints on a Spring application, or many different frameworks support Swagger. So in this case, I've added the two Maven dependencies for the Swagger framework. And under our application now, I'm going to add the Swagger bean. So let me do that. So now in our skeleton application, we have added the enable swagger to annotation. And we have a method that returns a bean creation method that returns a docket, which basically gives us access to the generated endpoints, or it will generate the endpoints for the web services testing. And it would basically scan any path for controllers that have endpoints available. All right, so now I think we're ready to basically build the application. We have a Swagger enabled. We have all of our dependencies in place. So the next thing I'm going to do is basically bring in a new model called person. And our domain is going to be very simple. Let me refresh the app here. Our domain is going to be very simple. We're going to start with a person model. And the person model is a very simple POJO here that has it's annotated with the document annotation. And this is the annotation that comes from Spring, from Redis OM Spring library. And this marks a POJO as being serialized and deserialized as JSON into Redis. I also have a few Lombok annotations to basically simplify the code. So I just have to have our properties. And notice that we have an ID, which is a string. It's annotated with the traditional Spring Data ID annotation. But when used in the context of Redis OM Spring, this is going to generate something called a ULID, which is an improvement over the generic UUIDs that most frameworks use. The ULID allows us to, basically it's a faster generation UUID, and it's sorted by a timestamp that's embedded in the UUID. So you can do some interesting things with IDs and ID ranges when you're using ULIDs over the traditional UUIDs. On top of that, we have several fields, and notice that we have a first name, a last name, we have an integer age, we have something called a personal statement, we have a Spring Data geopoint, which is going to be the home location. And we also have a set of strings that are going to represent skills for that specific person. So let's talk about the index annotation. In the index annotation here, it's a generic indexing annotation that says, for this specific field in the object, I'm going to create a mirror element in the search schema in the search engine that lives in Redis. So the index, for example, for a string field, will create a tag index type field. If you see down below, we have the same annotation, but this time applied to an integer. So when index is applied to an integer in the search engine schema for person, there would be a numeric search index field in that schema. And it does similarly for example, a point. It creates a geo index for that field. So index, it's smart enough to basically look at the data type that it's acting upon and creating the adequate search engine field in the schema. Also, in here, we have another annotation called searchable. In searchable, it's very similar to index, but it applies to text-like fields, and it gives you the ability to do full text searches over those fields. So for example, personal statement, it's meant to be a block of text, and we'll be able to search over that block of text using full text capabilities. Now, we also want to show the capabilities of the framework to work with more complex data models. So we're going to add an address class that is going to be a part of our models. And let me refresh here my IDE, and now we should see the address class appearing. When I open that class, you can see that it's another fairly simple POJO, but this time it doesn't have any annotations for specific serialization. But it does have an index field for the house number, a searchable field for the street, and then city, state, postal code, and country are indexed. And now the fun thing about this is that in person, we also added a reference to an address. So a person will have an address, and notice that address itself, it's marked with index. So the index annotation can crawl into sub-objects and then create nested indexes. So we can do, for example, searches by a person's address, street, or by the postal code, or similarly. All right, so we have our model in place. We have our application has everything that we need to test it. So now the next step, it's going to be to add a repository. And repositories in Redis OM Spring are just like any other Spring Data repositories. So let me refresh here quickly so you can see that now we have a skeleton models repositories package. And under that package, I have created a people repository. And notice that the people repository extends a specific type of repository called a Redis document repository. And like most Spring Data repositories, we take the object that the repository manages, in this case, person objects, and the type of the primary key, which is our ULIT ID annotated field, which is a string. And with this, you're getting a Redis document repository extends. Let me do a little spelunking in here. Oh, we don't have the source. I apologize. But this extends the CRUD repository and the paging and sorting repository. So all the CRUD functionality that you expect from a repository, it's already implemented for you dynamically when the application starts. So all we need for the basic CRUD functionality, it's an empty repository declaration. Now, once we have the repository in place, we also need to do one more thing to our application, which is to enable our document repositories. And notice in here, I have my annotation, enable Redis document repositories. That is part of a Redis OM Spring library. And I'm telling it to scan the base packages under my skeleton application. So very traditional enable repository annotation. Now, with that in place, we'll probably want to have a way to test our repositories. And likely the easiest way to do that would be to basically create some data using the repository itself. So I'm going to load some test data, and let me refresh this. And now I've added, let me zoom in. So I've added a command line runner bean that it's going to load our test data. It takes as in the parameters a people repository, which is our repository that we created earlier. And notice that inside of that, I have an access to that repo object. And I can, first I'm going to delete all the data. So every time that I run or reload the application, we're going to basically clean everything and start anew. So I'm deleting using the delete all method to clear the repo. And then I have a string here for the personal statement. And this is, I'm using Marvel characters in here. So I really enjoyed those movies with my kids. So we basically went and hunt for things, funny things that the Marvel characters have said. So in this case, I have Thor saying something funny. And then I have an address for the, well, this is not a real address, it's somewhere near where he actually lives, Chris Hemsworth. And I have an address in Australia, in South Wales, I believe. And notice that the person object, I'm using the constructor, the factory constructor provided by Lombok. Passing the first name, last name, age, the personal statement, a geo point for the address, the actual textual address, and a set of skills. And on the skills, we have hammer, biceps, hair, and heart. And then we're using the repository save method to save that object to the repo. So why don't we start the application now? In this being STS, we have a very convenient way to run the application. So I'm going to, oh, actually, before I run the application, let me do a quick preview of what we have in Redis Insight. So Redis Insight is the preferred way to basically inspect and manage data in Redis. And this is a preview release of Redis Insight. I believe this is version 204 preview, which you should have access to by the time this video hits the streams. And it has the traditional CLI. So if you are used to the Redis CLI, you have it now built into this application. Oh, let me reconnect. Okay, so we have our CLI available to us in this beautiful UI. And I can, for example, say module list. So we can see the modules that are loaded in our version of Redis Stack. And notice that we have a time series, our search module, Redis JSON, graph, Bloom filters. And you can also see here at top the different modules that are loaded with Redis Stack and their versions. All right, so we can refresh here. This will basically give us a display of all the keys. A page of the keys that we have. There's nothing in our database, so there's no keys to be shown. So now let's go back to our IDE, and I'm going to right-click and say run this as a Spring Boot app. And that's a nice thing about STS is that basically Spring Boot is native to the IDE. So I'm starting the IDE, and as you can see, it found some of our index in document annotations, in index some of our created index on our behalf. And if we switch now to Redis Insight, we should see that if I refresh our keys, now we have two keys. And if I do, for example, I can use an FD underscore list to see the list of search indexes that have been created. And Redis OM Spring created this person IDX index. And you can see it matches the fully qualified Java name of our POJO plus the IDX suffix. And we have the two objects that were created by saving that person POJO for Thor to the database. So let's inspect the set. So if I click on that set, this is the traditional scheme that Spring Data Redis uses to keep all the set of primary keys in a set. So we have only one primary key in there for our object. And then below, we have the actual object, which is our JSON document that was stored in our Spring Stack, in Redis Stack, sorry. And you can see that we have a nice viewer here for our JSON. It has the ID, which matches the ID that we have here in the set. And we have the first name, last name, the age, the personal statement, the home location, the Spring geolocation point class. It's properly serialized as a Redis lat long. And if we click on those ellipses, we can expand the sub-object address, and you can see that we have all of the data in our address properly stored, and our set of strings was also turned into a set of skills in Redis. In our JSON document, it's a dictionary, basically. All right. So now that we have that data, we see that the repository works in terms of saving data. So now let me switch back to the IDE. Okay. We're back to the IDE. And we're going to leave the application running because any changes that we have now, since we have the DevTools enabled, it should reload. All right. So the next step, it's going to, let's just load the full sample of people that I created in here. So I'm going to refresh this, and now you'll see that we have multiple people. So I have Thor, Iron Man, Black Widow, Wanda, Gamora, and Nick Fury. And here's all the data for those 6 objects. So we should have now 6 entries of type JSON in Redis, and we should have 1 set to keep the primary keys. And as you can see, I switched from save to save all. So all the traditional CRUD methods that you expect to find in the repository are there, and they do the right thing. All right, so let's go back to Redis Insight and explore the data. So if I refresh my set of keys, you can see now that I have the 1 set that we had before, and we have 6 JSON objects in the database. Since we deleted everything on the application restart, the primary keys will be new primary keys. But of course, that doesn't really matter because we're not doing anything based on a specific primary key. But here's the old Chris Hemsworth object. And now we have Scarlett Johansson, we have Elizabeth Olsen, we have Robert Downey Jr., and Samuel L. Jackson. All right. So now that we played a little bit with our data, let's take a look at what powers the ability to have these repositories and search capabilities in Redis. So previously, I used the ft._list command to list the set of indexes created in the database. And now I'm going to use ft-info to get specific information about that person IDX index that was created by Redis OM Spring. And if we scroll up to the top, you can see that we have the person IDX index, and it's a index on JSON keys. It will index anything that appears as JSON with the prefix on the key that matches the package name of our object, followed by a colon. And if you remember, all of our keys are generated using that package name prefix, colon, and then the ULIT that gets auto-generated. You can see here that now we have the schema for the fields. So I have the identifier has been indexed as a type tag, and this is the most generic index field type, which basically allows you to do exact searches on those values. Down below, you can see that we have a first name and last name. Those were also tag indexed. And if we look at the personal statement, for example, this was indexed as text. And those are the full search capability fields. If we look at the postal code, those are tags too. Let's see if we have anything else here of interest. We have the home location. Again, remember that was a lat long, and that was indexed as a geotype. And the H was indexed as a numeric type. So it gives you different capabilities based on the type of index that was created in the schema. Okay, so now we're going to add a controller so we can test our JSON payloads over HTTP. So the first thing I'm going to do now is create a very simple controller. And let me refresh here. And now we have a skeleton.controllers package. And under that, I have a people controller v1. And I call it v1 because I'm going to create 2 types of controllers. One is going to be used in the repositories, and the other one is going to be using something called entity streams, which we'll talk about later. But this is not traditional, endpoint versioning. This is just, I happen to call them v1 and v2. So our people controller v1, it's anchor at /API v1 people. Notice that I'm bringing in a repository, the people repository that we created previously. And I'm auto-wiring that. You could use a controller injection, which is, constructor injection, which is a little cleaner, but I am lazy and using auto-wire. I also added a simple endpoint called all, so it would be /API v1 people /all, and that is going to return all of the person objects in the database. We're using the repository find all, which is one of the built-in methods in the CRUD repository. You don't have to do anything to your repository definition to get those. As before, you can see that our repository is still just an empty shell. Inherits everything from a CRUD repository and paging and sorting repository. So with that in place, we can now, and the application should have restarted. So let me switch to a browser where I'm going to load our Swagger UI. In the Swagger UI, it's rooted on their localhost. Oh, there it is. So localhost 8080/Swagger UI should get you to the main page of the Swagger UI. And for some reason, it's not coming back. Let me see what I'm missing. Oh, there it is. So I was missing the slash. So localhost 8080/Swagger UI would get you to the UI for Swagger. Notice that we have our API. Let me refresh this. Seems to be picking up a okay, there we go. So you get a basic error controller. You can ignore that. That is part of the Swagger tapping into everything that Spring provides. But our people controller version 1, it's here. And if we expand it, you can see that we have a get all, and that's the endpoint as we declared it in the controller. So if I expand that, you can see that we get a section for the parameters, and then we can basically click on try it out. And since this doesn't have any parameters, there's no parameters, I can just click on execute. And I should get now in the response body, as you can see, we have all of our JSON objects properly serialized back out to our web service endpoint. So that's pretty nifty. You get all that functionality for free. With Swagger, you can even download the payload, but you can see how the JSON gets serialized for HTTP endpoint consumption. All right, so now let's go back to STS. And under STS, now let's add something to our repository, or actually to our controller, so we can do a few more operations with the built-in CRUD functionality. So I'm going to now, on our controller, added one more endpoint. And this one, it's going to be to get a mapping by ID. So notice in this one, I have the ID value in curly brackets, which means that it's going to be extrapolated from there into this ID variable in this path variable. And then I'm going to pass that ID to the repository find by ID method, which is another built-in method that we get for free. So let's go back now to our Swagger UI. And on our Swagger UI, I should be able to, let me refresh. All right, and now we have two endpoints. We have the people by ID, and then we have the all. So I can expand that, click on try it out, and let's go to Redis Insight and grab ourselves an ID to try this. So I'm going to go to Redis Insight. Let me refresh the keys in here. And actually, we can grab it from the set. So I'm going to click on the set here, and let's just pick one of these. I believe that I can Can I copy it? All right, so I copy the value. I'm going to go back to Swagger, and assuming that it did copy it to yes. All right, so we have the ID that we grabbed from Redis Insight, and now I'm going to hit our endpoint with that, and we get back the record for Scarlett Johansson. So again, all the CRUD functionality you expect to have, it's generated and built in into the framework, just like you would expect from any other Spring Data repository project. All right, so now let me go back to our STS. So back on STS, next step is going to be to enhance a repository. So I'm going to go to the repository now and notice that I've added a custom method. In this one, it's one that actually will exercise the underlying search engine that Redis is providing to back all the complex repository interactions. So in this case, I have a finder that is going to find persons with an age in between a minimum age and a maximum age. And to do that, we use the find by, then the name of the field that we are targeting, which is going to be the age field in our person object. So remember, we have an integer age field in our person object that it's indexed. And obviously, you can only create searches against fields that have been indexed. And the between predicate basically tells the underlying repository that we're going to expect two values, and it's going to be a range search. So with that in place, first, let me go to the Redis Insight preview. And one of the things that I didn't show you before is that we have a profiler. So I'm going to start my profiler so we can see what commands hit Redis. So the profiler has been started. And you're going to see pings for info that basically come frequently. So Redis Insight can check on the instance of Redis that it's going against. So we can ignore those. But now, with that in place, let's go to our Swagger UI. So I'm going to go back to the Swagger UI. I'm going to refresh. And let me collapse that. And notice that now we have a endpoint for age between. So I'm going to expand that. And I'm going to click on try it out. And in here, let's see, let's do from age 30 to age 40. Let's see which people in the database, their age is between those two values. So I'm going to click on execute, and notice that we get how many hits? We get 1, 2, 3 hits. So the first hit is Chris Hemsworth, whose age is 38. And then Scarlett Johansson, 37. And Elizabeth Olsen, 32. All right. So now if we switch back to Redis Insight, you should see here on the monitor the query that was executed against Redis Search, the search engine powering all the search capabilities in Redis. So we have an FD search call to the specific index that we created, person IDX. And notice that it's at age, colon, bracket, 30 to 40. So that is a Redis OM Spring creating the query that matches the repository signature. Perfect, perfect. All right, so let's go back now to STS. And that is a simple range query, numeric query. Now let's try a query by multiple fields. So we did hero by one field, find by age. Now, refreshing this, notice that we have now a find by first name and last name. So in Spring Data, the convention is that any of these finders, you can daisy chain multiple fields, is supported by the platform using the and keyword. So in here, we have first name and last name, and the method itself takes two parameters, the first name and the last name. And that's all you need to do. Remember, no implementation needed for this methods. Spring Data, one of the great features of it is that it can take this name declaration in the parameters and result values and figure out what you kind of want in your query method. So we have find by first name and last name. Now let's switch back to our Swagger UI. In our Swagger UI, I can again just refresh the whole thing, and I should now have 4 endpoints. And here's our by first name and last name. And I can click on try it out. And let's try Robert Downey. I think that's how I named them in the database. And yes, we get our record back for Robert Downey Jr. And if we again switch to Redis Insight, in our monitor, we should now see that there is a query for first name, and notice the curly brackets for tag searches. So that was a tag annotated field. So we get Robert for first name and Downey for last name. And this is an ANDed query because we have two values in there. All right, excellent. Okay, so now let me go back to our STS and let's try a few more custom queries. So the next one, it's going to be a geo query. So if we refresh, now you can see that I have a find by home location near. So again, the prefix for our finder, it's find by, then the target property, home location, and then the predicate, it's near, and that basically tells our repository implementation that we're doing a geo query. So it will take a point to center the search in a distance for a radius around that center point. All right, so that's really all we need. The declaration in our repository. And if we go back to the Swagger UI, once again, I can simply refresh this UI. Let's collapse the method that we're playing with previously. And here's our API v1 people home log by home location. And I'm going to have to cheat and find some values for this. So let's click on try it out. And let me see if I can find some values that I have stored in here so we can try that. So I'm going to use a 10-mile radius. And my latitude is going to be minus 28.71. And my longitude is going to be 153.59. And this is somewhere in Australia. So you could guess who is going to be in our result set. So I click on execute, and we can see the lat long URL in the URL in the distance. And here we can see that the response, it's Chris Hensworth, who lives in 7 Mile Beach Road, somewhere in, I believe this is South Wales in Australia. And again, switching back to Redis Insight, we should see that geoquery in the UI. You can see there that we have home location, and it's like a range query, but notice that it has the two values for long lat, and then the distance radius and the unit. And I hard-coded miles in my query, but you could have used something completely different. So let me show you where I did that. If you go to the controller, where we have the home location, notice that I take the double lat long and the distance, and then I create a new point to pass the lat long, the long lat. And the new distance, it's passing the distance value provided by the request to the endpoint, and I hard-coded miles in here. But you could very easily also have a drop-down for the distance metrics and pick from the right values based on location. So I went full American and just picked miles. Now let's try a query using the full search text capabilities. And if I refresh my repository, notice that I just added a search by personal statement. And notice that the difference between this method and the prior methods, it's that we use the find by on the prior ones. And if you tell Redis OM Spring, and if you use the prefix search or search by, then it assumes that this is a full text search capability, but it will also check the underlying field. But in this one, you basically get search by personal statement, and that should execute a full text search against that field. So we have the method in the repository. Now let's check the equivalent method in our controller to expose that to the outside world. So again, we have an iterable person as a return type, and we're mapping this as a slash statement. And we're taking one request param called Q for the query, since this is kind of a free text search. And then we call our newly created search by personal statement repo method. All right, so now with that in place, let's switch back to the Swagger UI. And in the Swagger UI, I'm going to, once again, refresh. And let's collapse the prior one that we use, home lock, and expand the by personal statement endpoint. And notice that we have our by personal statement endpoint. It has one simple query field. And in there, let's try a few different things. So I'm going to click on try it out. And let's try mother. And I believe in one of the personal statements, I believe it's Robert Downey Jr. uses mother to make fun of Thor. So in here, yes, we get doth mother know your weareth her drapes, and that it's in Robert Downey's personal statement. So now notice that I can, let's see if this works. If I do moth star, I should still get that result set. So you can use wildcard searches just like you would expect to use in a search engine. Perfect. And that is how easy it is to do a full text search in Redis OM Spring with Redis Stack. If you had, so one of the things that I actually didn't show in here, it's that if you had multiple fields that are annotated as searchable, you can have, there's a magic method. If you create a repository method just called search, and that takes a string query, that will search over all of your searchable indexed fields. So if you have multiple full text search fields, by creating a single method called search, you can search over all of them in one single method. All right, so that was full text search. Now next, let's do a method that searches inside a sub-object. So remember, we had a person object and we had an address inside of a person. So we want to search by some properties of the address for a person, but we're gonna get person result objects back. So let's go back to STS, and on STS, let me show you. I already added that method. Let's see. Go to the repository and notice that there is a find by address underscore city. So in Spring Data, the convention is that it's to navigate into a nested object, we use an underscore. So like before, we have a find by, the field that we're targeting, which is address, and then an underscore city to go into the subfield of address that we want to search by. And our value takes our method takes a string parameter, and then our equivalent controller method, we're mapping it to city, and we again take a request param of city and call our repo method. It's that simple. All right, so now with that in place, once again, let's go back to our Swagger UI and do the same two-step dance, refresh it. Let's collapse the prior one. And here's our by city. And I'm pretty sure I'll click try out. And I'm pretty sure that we have a few folks here that have New York as the city. So I'm going to type New York, click on execute. And now I should see Scarlett Johansson, which is in some random address I picked out of New York, 48th Street. And then Elizabeth Olsen, she is on West 34th. And those are the two New York-based folks that we have in there. So let's go back in here and see if we have anybody in Los Angeles. And I don't know if I was fully spelled Los Angeles or yes. So we have Zoe Saldana or Saldana, and we have Samuel L. Jackson in the LA area. All right, perfect. Now, once again, let me switch to Redis Insight. And in Insight, we should see that here are the address city searches, one for New York and one for Los Angeles. Excellent. All right, so let's go back to STS. And what are we going to do next? Let's see. Okay, now remember that we have in our person object, we have a field that is a set of strings called skills. So in our repository, I've just added a method to search by one of multiple skills. So you can pass a list of skills in here, and if any of those skills are in any of our person objects, you're going to get that as a result. So notice again, the same thing, find by skills is the field, and then just by passing the set in the type of index field, the framework will basically know what to do. In our controller, again, we have a method called by any skills, and it takes the request parameter skills, which also it's a set, and we pass that down to our repo. All right. So same deal as before. Let's go to Swagger. Let's refresh. And here's our skills endpoint. In Swagger, it's actually really nice because when you have something like a set, it allows you to add individual items in there. So let me find some values in here. All right, so I'm going to add an item. And once I add an item, I believe that two of our Marvel characters have deception as one of their skills. So we have deception in there. I can click on execute. And you can see now that we have Scarlett Johansson, and on her skills, it's deception and martial arts. And Samuel L. Jackson also has resources, deception, and planning. All right. And like I did before, let's take a look at Insight so we can see what the underlying search engine query looks like. And noticing here that we have our deception curly brackets. This is a tag field search. And that's what it is. Very simple. All right. So once more, let's go back to STS. And the next thing I want to show you, it's a very similar query method, but this one, it's an and condition. So before, when we did find by skills, we find by any skills. So implicitly, it's an or condition. If you wanted to make it an and condition, you tag in the suffix all to the end of the, containing all, it's going to be the predicate to basically trigger this and condition of all the skills being passed in the search. So we have find by skills containing all. And again, the parameter is the same, a set of strings containing the skills. And similarly, we have a pass-through here in our controller. So with that in place, once again, let's switch to Swagger. And let's refresh. So now we have a find by all skills and find by any skills. So let's try the by all skills. And obviously we would need a list of skills that matches the person we're looking for. So let's quickly switch to Redis Insight. And let's inspect one of our keys. I'm going to collapse this a little bit. And let's pick this one right here. Oh, sorry. Let's refresh our keys. Remember, we keep on destroying and recreating the data on every refresh of the app. So let's look at this one. And oh yeah, so let's grab Zoe Saldana. That would be skills in martial arts. Her skills are skills. I was very creative on that one. Okay, so I'm going to switch back now to Swagger. And under all skills, let's expand that. Click on try it out. And one of the skills is going to be martial_arts. I believe that's what I used. And the other skill, it's just skills. And if I click on execute, we should get Zoe Saldana back. And now notice that, so there's a record so you can take a look. And let's say that I go and remove skills and I execute again. Now, the only one that has martial arts. Oh, interesting. Oh, I see. I see. So the behavior is not quite find all. Notice that if I do martial arts, now it went back to the ones that have that skill, martial arts, regardless of whether it has another skill. But if I do, let's say, add a deception in there, I should narrow it down now. So I'm going to do add item, and I do deception, and I execute. Now it should just have Scarlett Johansson. All right, so that's a variation on a tag search, basically set operations. And let's switch back to STS, and let's see what's next. All right, so I'm going to stop right here, and then we're going to be talking about entity streams. Now that we've seen how querying works through repositories, I want to show you a different way to query for JSON objects in Redis. And this is an API called Entity Streams. And the Redis OM Spring Entity Streams provides a Java 8 Streams API to query Redis JSON documents using Redis Search. And Entity Streams allow you to process data in a type-safe, declarative fashion, similar to a query builder for SQL. But streams are type-safe, and they follow the semantics of how Java developers are accustomed to manipulate collections. So entity streams and Redis OM Spring, they provide the same semantics as Java 8 streams. The streams can be made of Redis map entities. So the person and address objects that we have mapped as documents, they are the result sets that you would get from an entity stream. Entity streams give you this query builder that can progressively build a query until a specific terminal operation it's called So for example, in streams, you will call collect and then grab all the objects from a collection into a list or a set or a map. The same semantics apply to entity streams in Redis OM Spring. So to get started, the first thing I'm going to do is bring in a new controller that we're going to use to exercise our streams. And I just added a new controller. Let me refresh our application so we can see the new controller that should be under our controllers package. So as you can see, there is a people controller v2, and this is the one that we're going to use to exercise entity streams. So how do we use entity streams? The first thing that we need to do is bring in an instance of the entity stream, and you can inject it. You can auto-wire it. You can add it to the constructor of the controller. You can use it in a service, and you can even use them in an implementation of a custom repository. So if you wanted to have a repository and there's a method that would be too complex to implement with just a repository naming conventions, you could use an entity stream to back the implementation of such a method. So in here, notice that I brought into this controller, which is under API v2 people, an entity stream class. And that comes from our Redis OM Spring Search Stream entity stream. So once you have the entity stream instance, you get to use it. And to use it, we're going to add a method that it's going to be a mirror method to our H between finder that we had in the controller version 1. So if you remember, going here to controller version 1, we had a method by H between that took a min and a max, and then called the repo by H, find by H between. So if you remember, this is how we declare this method in the repository. So now we're going to explicitly build that query using the entity stream. And in here, since we don't need a repository, all we need is an entity stream. In the implementation of our by H between method, again, we take two request parameters, a min and a max integers, and then we use the entity stream instance, and we say of the specific entity that we want to return. In this case, would be a person class. So entity stream of person, and then we're going to filter. And we're going to filter by the H being between those two values being passed. And then we're also going to sort it by that H in ascending order. And then what I was talking about before, the terminal operation, it's collect. So in here, the query, it's progressively being built. And when we call a terminal operation like collect, then the query will be executed against Redis, and the result set will be then serialized back to the type of objects that we're expecting. So notice too, that we have this person class with a $sign at the end. And this is a meta class. So for each one of the annotated entities in your system, we generate a meta class that has operations that match the type of index field that backs that specific field. So for example, in our case, the person $object, it's in the same package as person. You can see here the imports. And it has, in all caps, property fields that match the fields in that have been indexed. So for example, we have an H field, and since it's a numeric index field, it provides a between operation given a min and a max. We can also use the H meta class field to tell the entity stream to sort itself based on that field and given a specific sort order. So let's save that. And now we can switch back to our Swagger API and test the new method. So notice that we have now two controllers, people controller version 1 and people controller version 2. And we have here the by H between for our new controller using the entity streams. So I'm going to click on try out, and let's try again some H ranges. So if I remember correctly, we have some folks between 30 and 40. And if I click on execute, I should see now that I get Elizabeth Olsen at age 32, Scarlett Johansson at age 37, and Chris Hemsworth at age 38. And I noticed that they are the result set, it's arranged by the age. So let's see, let's lower this down to 35. And we should get now a single result, which is only Elizabeth Olsen. And let's move it up to 37. And we should now get two results, Elizabeth Olsen and Scarlett Johansson. Again, the result set order by the age. So let's switch back to STS, and you can see that this provides us a very fluid, type-safe way to build queries in Redis Stack. So now let's move on to the next feature. So now we're going to implement the same by first name and last name method that we did before, but using entity streams. So here's our by first name and last name finder. Notice again that we return an iterable person. And once again, we use our entity stream of person. And then we can use two filter calls in a chain. So we can say filter by the first name of the person being equals to the first name being passed, and filter by the person's last name with the name being equals to the last name. Again, the operations that you get off the properties of the meta model will match the capabilities of the underlying search field created in the schema. So once again, let's switch to Swagger, and I'm going to just refresh the UI, and let's collapse the prior method. And you can see here that we have another slash name by first and last name. And let's try here. Oh, let's click on try it out. And we can try Robert Downey. And we execute. And we should get our result set for Robert Downey Jr. Again, it's a very explicit way to generate a query. And it's a contrasting approach when you compare it to something like repositories. Repositories are completely magical. They do everything for you based on a method declaration. But sometimes for very complex queries, even the naming convention can get very, very hard to follow. So in our case, if we have complex queries, we can switch and we can mix and match. We can have repositories with extra methods implemented using entity streams. So let's see. So I'm going to add one more method in here, and then this one's going to be the by home location method that we did before. So again, we're taking three values, all three doubles, lat, long, and distance. And once again, we use our entity stream of person, and we're going to filter by the home location being near a given point at a radius from that point. So again, all the semantics that are required for this specific field, home location, which in the person class, if you remember, it's a point, it's a Spring Framework data geo point. Notice that in our controller, we get the field of the meta class has the correct operations to deal with geo searches. So we have our near operation, and then we pass a new point in a new distance, and that's all we need. So let's go back to Swagger one more time, and we'll refresh the UI. Let's collapse that one, and there's our home lock value. So I'm going to click on try it out. And again, for the distance, I'm going to pick 10 miles. And once again, I'm going to pick a location that it's somewhere in Australia. And if I click on execute, I should get the only resident of Australia in our data set, which is Chris Hensworth. As you can see, the lat and long values are pretty close. 153 and minus 28, we have 153 and minus 28, just different decimals in there, which is within those 10 miles radius that we're searching for. All right, so going back to our SDS, and to recap in here, you have two different ways to achieve search functionality over JSON mapped objects in Spring with Redis. Given that Redis Stack gives you multiple different data types to work with, JSON being one of them, and it also provides the ability to search over those values with Redis Search being one of the modules that Redis Stack provides. So now, from the programmatic point of view, you have two different ways to express ways to find the data that you have stored in Redis. And this same searching capabilities and mapping capabilities extend to Redis hashes, which Spring Data Redis supports out of the box, and we built on top of Spring Data Redis by enhancing those hashes to have full search capabilities. And other modules coming down the pipe would be Graph. So we are working on a set of annotations to make data structures, graph data structures in Redis also feel native in your Spring applications. And on top of that, we also have the Bloom filter data structure. So we have the probabilistic data structures, Bloom filters, cuckoo filters, all of those, they're going to be annotations that will allow you to use those facilities in your Spring applications without having to compromise your data in a model that does not fit the type of data you're working with. So stay tuned. And again, this is release 0.3.0 of Redis OM Spring. And there will be many, many more features once we reach 1.0. Thank you.